Hello, everyone. D. Alfred Ostrowski. In this recording, I'm going to be giving a tutorial/demonstration of an AAVE Flash Loan. In this particular example, I'm going to be performing it on a forked Ethereum mainnet copy. I'm going to be doing this on the Amazon EC2 instance as usual, and I'm going to be using the same installation as I have used with the prior testnet Sepolia video demonstration. So if you already have that, you might skip ahead a couple of minutes because I'm going to cover that. I want to make this comprehensive. And as usual, I'm using the Amazon EC2. I can give you a solution and you can reference my GitHub. You can cut, paste, and work along with this. And in most cases, the goal here is an exact duplication of what I have. Regardless of what your environment, this is a great tool for testing. Now, in this example, I'm going to be using the Hardhat console commands and nothing else. I'm going to use Hardhat and fork off the mainnet Ethereum and then do the rest through the console commands. And the only difference between this and the last two tutorials is I'm basically combining the mainnet forked Ethereum demonstration with Hardhat in conjunction with the Sepolia testnet video for two exceptions. Now, when I'm working with forked Ethereum, I need to be interested in doing a couple extra actions here. In this case, I'm going to want to do an account impersonation to pull in my token balances because I don't have a faucet as I do with AAVE providing that for the testnet Sepolia. I have to do a account impersonation to accomplish this. And I'm going to look at directly at the transaction logs, which I haven't done prior because I don't have an Etherscan IO on the mainnet. I do, but I can't validate my transactions using that. So I'm going to use it to validate the transactions and feel good about everything. So let's get started. I'm assuming, as usual, that you have an Amazon account, PPK key generated, and a means of accessing the client. I use Putty. Okay, so let's get started. And again, moving forward, I may just wrap this up in a separate video, but however, sometimes I have some nuanced changes, and it's nice to have this all comprehensive. But again, if you already have this installation from the Sepolia testnet, because I'm not varying this, then you can skip ahead a little bit. Okay, so here are my instances. I'm going to launch my instance and get going. So this is usual. I'm going to use the Ubuntu and the C5 instance and the default Ubuntu server as usual. And again, I'm not installing a lot of software, so hopefully this isn't a huge burden. I'm going to get the C5. I don't want the C5 4X. I can get by with C5 large, just regular. There we go, as usual. And again, I want this to be an apples for apples comparison, and you may be running a separate architecture, right? But 20-30 minute investment, you can have working example as opposed to maybe an example that you're going to do some administration. It's always nice to have something that is working. That way it gives you a good point of reference. Let's refresh this and I should have an instance. There we go. Come up here and grab my IP, and I'm going to bring up my terminals. I'm going to bring up two terminals here as opposed to the Sepolia demonstration, because here I'm going to be running the node locally with my forked Ethereum. Pull it in here. And I'm going to run the console in another node as well. So bring in the separate, and again, you could even run, they have console commands here. Here I can run this a little bit larger, a little more visible. So that's why I use it. And again, as usual, I don't default use any passwords here by default because I'm going to use this just as a sandbox, and I can stack these and we can monitor in the background in the node to make sure everything's running appropriately. And as usual, I'm taking all my commands off of my GitHub page, and I have a README install where I have all of the specific commands, so you don't have to stop and rewind and validate that you're getting the exact same commands here. So in most cases, you should be able to cut, paste, and go along with this video even at the point where I'm just presenting it, right? So again, here we're demonstrating the mechanics and trying to give you much of an explanation along the way here. And again, the challenge of working in the forked mainnet is that I want to validate and make sure that my activities are working as advertised, and I have a good confidence of exactly what's going on. So in an earlier version with the Sepolia testnet, I actually had such a low amount, I didn't have to worry about the USDC. So primary challenge here, as usual, okay, is I have to have the token in my account. In this case, it is specifically the contract address and not any other external address. I am using one of the accounts for the deployment. That defaults to the initial contract that is presented. Here, I'm just doing the install Node.js. It just prompts me to restart the services, and that's what I did there. So I just tabbed through and hit the installation. So the earlier versions of Node didn't have that right here. So here I'm installing the Nomec Labs software and ethers, and I'm going to be relying that in the Hardhat console. I love the Hardhat console, okay? It gives me a means to test my JavaScript code, because at the end of the day, Remix is obviously a powerful tool. It's extremely valuable, but it's abstracting me from working directly with the network, right? And at the end of the day, my application is going to be JavaScript, not Remix. And it may be in React, maybe even a standalone script or bot or arbitrage script, but it is going to be JavaScript. So this puts me in a little bit closer contact with that. I'm also installing the Open Zeppelin contracts. I might be able to get by without that, but I threw that in anyway. I'm going to be leveraging that in future content. And as before, I leverage the AAVE libraries. I install them directly. Other people have referenced them directly through the net to the GitHub. You can do that. This worked best for me, so that's the way I did it. Again, I'm pasting directly from my README install. So here I created my project directory. Let me CD to that. I called it Forked Ether AAVE Flash. And as such, I'm not doing arbitration. I'm not doing a DeFi app. I'm just borrowing the money. And I am giving it back directly with the premium. Okay, and that's it. Nothing more. We're starting small. We're stepping into arbitrage types of applications very lightly with a number of small demonstrations, and I hope to produce future content that will get you deeper into the world with very practical examples exploring the mechanics of this. I really encourage you to take a look at the AAVE documentation to make sure you have full confidence of what you're doing and that you have a complete understanding of what's going on here. So here I'm going to create the project directory. I just default through and accept the prompts. This is going to come together very quickly, right? I'm going to replace the Hardhat config, some slight variations from the AAVE version, and put in my Flash Loan, and we're going to hit the console and start deploying and working with our Flash Loan contract, okay? So I'm up. I have Hardhat installed, all my software installed. It didn't take me very long. Let me edit, and I'm using VI, very antiquated editor. It's suiting my needs. I'm not writing code on the fly. I'm cut pasting, so I don't need an extensive editor in this case. And let's face it, VI is very accessible. One thing I need to edit every single time for this specific implementation is I have the DNS, right? So remember to change that. If you don't, then you're going to be scratching your head. Well, why doesn't it work as it was advertised? And you're going to get a new DNS every time you come up, okay, if you're not well-versed, right? So here we go. I'm going to put that in, and let's step through this, okay? There's not a lot to cover. I'm pulling the Hardhat toolbox. I have the module exports directory and the networks defined under Hardhat. I have localhost. If you're doing this on your local machine and not using web service, you probably set the 127.0.0.1 or localhost itself. The chain ID is usually 31.337. I'm not too worried about this. I'm not using MetaMask in this particular example. I use forking. I use the URL, the default cloudflare-eth.com. Other alternatives would be Infura or Alchemy. You may have an account. You can use that just as well. Got to remember here, we're forking mainnet Ethereum and not Spolia. So we want to know the differences between, and obviously like me, so I'm not using my Infura account, or it's not really best practice to show those keys out in public. I'm not worried about this DNS. I'm going to blow it away when I'm done with the recording. And I'd encourage you, if you're not keeping it, you might want to back it up, and you not want to keep those instances up and running because it might run up in a substantial bill. Or if you're in the free service, it'll burn out your free service by the end of the month. So keep an eye on your billing. Just want to keep reminding you of that if you're not a huge EC2 person, right? So there we go. Hardhat config.js, it's set, it's good to go. Let me go to the contracts here, and I'm going to bring up a new contract. If you're not familiar with VI, there's a lot of tutorials online, and here I'm just using just some of the basic commands. And if you saw the testnet Sepolia, I'm using the exact same contract from that, right? So I'm going to step through this, but not to the greatest degree. If you want to get a little more in-depth on this, you might want to look at the prior video, but this is unchanged. It's unchanged from that reference as well. And it works fine as it should. But let's step through. I just want to point out a few things that are relevant here. And where things are being referenced. So I'm pulling in Solidity. I'm using 8.10, and I pull in the relevant libraries. I installed that with AAVE. So here I extend Flash Loan simple receiver base, and in that constructor, I'm pulling in the pool address provider. Now in that pool address provider, and I paused out just to pull in the associated documentation here. What am I passing into that, and how does this vary from the testnet? I'm going into the AAVE developers documentation, v3 mainnet, Ethereum mainnet. Okay, so that's a difference. You don't want to confuse the two between those contract addresses. Here I'm taking pool address provider, and again, this is under the developers of v3 Ethereum mainnet, v3 contract ending with 4E 9E. That is going to be specifically placed in the contract when it's being invoked, right? So we want to keep that in mind as we move forward. But that's what's being sent in here as an address in the constructor, okay? So let's keep that in mind as we move forward. Now, execute operation, that's the callback function, right? That's being passed, and the key parameters here are asset account premium, and the other two, the initiator and the call data params, those are just defaulted, okay? Asset is what? I'm asking for a token. What's the difference between a token and the Ethereum? Why don't we just borrow Ethereum, okay? We don't use that because with the token definition, it allows for higher level of programmability, in this case, supporting our DeFi application. So we convert in token, and it creates, again, an extra step here with the forked Ethereum, because I can't just grab my tokens from an arbitrary faucet, because I have my own world, my own environment that's created by forking off the Ethernet mainnet. So that's why I have to find an account to impersonate, and I'm going to impersonate it and take the money in my little sandbox world. This is a legitimate technique, okay? This is a technique that is one of the reasons that people go to Hardhat, right? Because it provides a little bit more support than you would otherwise. But the reason is being, and that's why I point out while I'm in this contract, and again, dig into this. It's going to give you a little more insight as we work into more sophisticated applications as related to arbitrage, that the amount owed is in account and premium. Well, if I'm borrowing in that token amount, my premium needs to be in that amount because it's all added up in the amount owed. It's not two separate values here. So it has to be the same unit, monetary unit. So for that reason, I loaded in the token. So the reason number one is that's why I use it. And that's why I have to use it for the premium, right? So, and that it goes through the approval process. This all supports that theme, right? I need an indivisible action and it's going to be approved before it's actually executed, right? So it all happens in one fall swoop. And I want to make sure that it's working appropriately. And also I want to make sure that it did what it was supposed to do, okay, when it comes back. So this is initiated through the request flash loan, and I have the token and the amount. Again, those are the two major values of interest that are going to be passed in along with the receiver address. And that is this, meaning the current contract that's being deployed, not a separate account. And there, you can go through different variations, but in this case, it is the money sent directly to the contract itself, okay? And correspondingly, the token amount is going to be removed from that and sent back as part of the premium. And that is supporting the contract. And again, I have a slightly different discussion on the testnet Sepolia copy. You can look that up on the channel as well. But that's the bottom line. Okay, a little more insights going on. And again, as you move forward, you want to take a little bit deeper dive, and all the libraries are there. So you can go down to the AAVE code and see how they built that protocol. And that's going to be more and more valuable as you work within this construct to support more, complete applications. Here we're just going through the base mechanics of borrowing and giving that money back. Okay, not even in the real Ethereum mainnet, but we're very close right now, right? With the forking of that. And this is a fantastic environment to work in because it's not costing us anything. Obviously, we want to deploy the mainnet, that's going to cost real money. So we want to make sure I have all of our mechanics, the complete understanding. And this is a great way to accomplish that, right? So let's fire it up and get started. I'm going to do an MPX Hardhat node and bring it up with the host name localhost. So it's going to start up my node for me, right? In this case, it's going to be the forked Ethereum. And I have, as I've demonstrated in other videos, I have the advantage of these accounts of my phony money. And I'm going to be relying on that for the deployment and nothing else. So the first address of interest is the first default contract. That is this account 0 that I'm going to be relying on. And we can check the balance before and after, right? So confirm that. And that's the advantage of the console, right? I can print that out as I go along and have a complete confidence that I understand what's going on. And this is a great starting point, right? Whatever types of applications you work with, you can troubleshoot through the Hardhat console, and it's another way of checking on it, right? And you can use Remix as well, but I like this. And there are some things I see in other means of presentation where they're using Remix, but they got to jump out and jury rig something, okay, in the Hardhat console. So at the end of the day, this is really testing your knowledge. This is a great bridge between the two applications, not taking anything away from Remix. Obviously, it's a powerful tool and it's extremely valuable and obviously highly recommended. It's always best to know more than one way to doing things, right? So here I don't want to bring it up at this level, right? I want to be too much ahead of myself. I want to drill to my directory. In this case, if I do an npx hardhat, it's going to reinstall it, right? So be careful, I'm in the right directory here. And let me pull that back in. I just cut paste. And again, I'm cut pasting from my there's no sense in you watching me do typos, right? So pull in what I need to do, and we'll break it down line by line and step through line by line as we need to. So first thing I want to do, and again, I'm using the console to my advantage. I'm stepping through line by line and really validating what's going on and have the complete understanding. So setting up that network to localhost between the two, then I got the confirmation. Okay, I'm running off my local node. It looks like it's, I got that. It's always good to see that confirmation come up here. I can take signers and I can demonstrate to the screen. Those are my 20 accounts that just flashed by. Okay. And I can reference them as well at will. The only one I'm really primarily interested in right now before I do my deployment, which I'm ready for, is I'm going to take the address of the first account. Why? Because, and I didn't specify that, interestingly, this is very similar in nature to Ganache, right? It just takes that first account by default. I could probably specify any account through the ascend operation if I want to extend my deployment from the JavaScript. I can apply a send operation, but here I know it's going to default, and I can check it before and afterward. I can check it right now. So I'm going to take that ethers library, and I can check the account balance of S0, and there's my 10,000 ETH. Okay, that is with my 18 zeros appended. So let me deploy the contract here. Okay, didn't find my contract here. Let me go back, take a look. Oh, I named it inappropriately. Should be Solidity, not JS, right? So I could just copy that over. There we go. There we go. So I know it loaded appropriately, and it compiled and loaded that in the appropriate fashion, right? So now I can proceed, and I got my commands are buffered up here, so I can go back through and run this back through. Obviously, they're not saved between the two. Brought in my signers, and here I grab that address. I got my 10,000 ETH. That hasn't changed. And so now let me do the deployment. Okay. So it came back, it wrote to my version of Ethereum mainnet, right? And here I have a contract definition and the 4E9E. Okay, let's refresh it. So where did I get that? So that is my pool address provider, 4E9E. There we go. So that's where I got it from. And you don't even have to reference this. You can take it from my GitHub, but it could change tomorrow, right? AAVE could change it. At least you know where to get it, right? And again, as you proceed, I'd encourage you to, review the documentation, do your research here. We're basically doing mechanics and throwing in as much explanation as I can, okay, as relevant without getting too deep in the weeds here. Okay, so I have that deploy contract, and now I can grab that address. Okay, I'm going to put that in a variable as such. So I just do a get address on that, and I'm just going to keep that for reference purpose. Why? Because I'm going to impersonate my account and pass the ethers in there. Let me grab the balance and see what the charge was or the differences between the amount as I work through this, right? So if I do the Let me see here. That's it. Now, if you notice here from above, I have less than the 10,000 ETH. So that confirms what my understanding was, right? That I deployed my contract, and that's where I got the ETH, the regular Ethereum, not token, not wrapped ETH. Okay, this is the regular Ethereum. And the beauty of it is that I didn't spend that money, right? That's the whole beauty of using the Forked Ethereum, right? So I have that out of my free funny money account, and that is to great advantage because that way I can use it at will, right? I don't have to worry about it. So I have the deploy contract. So now I want to get some USDC and put that in my deploy contract. Okay, so how am I going to get USDC? First, I want to define the associated token. So I'm going to grab the contract for USDC, and I'm just going to pull it out here. But where did I get it? Okay, let me show you where I got that from. So const token, get contract out. It's ERC20 token. If I go to the Etherscan.io, click on tokens, and you're going to need to do this if you want to borrow a different currency, right? If I want to borrow Matic or DAI or whatever, okay, that you're interested. I'm using USDC. So I click in the USDC token and I grab the contract address specifically right here in the upper right. See, it's EB48. That's my node, and that's where I got it from, EB48. So that's where I got it from. Okay, there's my tokens. That's my token definition. And so if I take that and I go USDC holder, I can pull it in as such. And I don't have that defined. Okay, so I got a little bit ahead of myself. That is a holder of the USDC. So where did I get that? Okay, this is the account I want to impersonate, and I want to check that balance. Actually, I can check the balance at this point. Of my deploy contract, and that'll prove a point there as well. Now I use token, await token, again, for the purpose of making sure I don't have any race conditions and I actually get back the value that I should be getting back, right? So await, per its name, right? It's going to wait for the asynchronous action to return and make sure that I'm putting to the screen the appropriate amount, that it satisfactorily completed that operation, okay, which happens in an asynchronous fashion, right? So that's the whole purpose of await. And again, you can get a better feel for how it works and the dynamics behind it, again, by using the Hardhat console. So for that reason, it can be leveraged to great advantage. See here, if I have the USDC holder, so where did I get this contract amount? This is the account that I'm going to copy. So I can go to tokens, which I did before, and I went to USDC token, and under tokens, I click on holders. So I want to grab any of the top holders. In this case, I took the first holder here, copied his address. You see he has a substantial amount of tokens. I copy that address, and if I just copy down here, that's the same address that I pulled in there. So, and this may not work in the future, okay? So you want to go to Etherscan.io, USDC, click on tokens, and search for the holder of the token, which I did. And so we can take the balance of that and we can print that to screen. And just as I'm going along here, I want to confirm that everything is working in the fashion appropriately, right? So here I have 9374497. Let's look at his amount. 937. What was the difference? Yeah, 93744. It's close. Okay, so it's not going to be a mirror image real-time update of what's being demonstrated on the Etherscan IO mainnet, right? But this is close and obviously has enough that I want to borrow. I'm going to borrow or just transfer off the impersonated account. I'm just going to transfer one token, and I'm only going to borrow one USDC, and that's going to be a ton more than the fraction amount that is necessary for the means of the premium rate of definition. But I have to have more than zero, right? If I have zero, then it's going to conk out. It's not going to give you the appropriate amount. Now, interestingly, with the Sepolia earlier video, which I'm going to update, I use such a low amount that it actually didn't even require any tokens because it was such a nominal amount. Just let me skate by, but you want to do a substantial amount. This has to be set, and in this case, it has to be set exactly to the deployed contract address and not to any other extra, additional account. Okay, so to accomplish that, I'm going to take that holder. I'm going to prepare that for the account impersonation, right? So here I'm going to reset the balance on that account, okay? And here that's accomplished with Hardhat set balance, okay? So that prepares it. Otherwise, it's not going to allow for the impersonation of that account. So I need to do that reset or set balance rather. And then I call a send with Hardhat impersonate account. That's going to set it up appropriately. And now I can do a get signer on that, and I pass that into impersonated signer. And I'm getting true along the way, so everything's looking good. It looks like it's working appropriately. So again, on the token balance of my deployed contract, I had zero and I need more than zero, right? So I'm going to pass in that amount through to my deploy contract. Okay, so here's the transfer command that accomplishes that. Do transfer, and I'm going to transfer this amount, and this is specified as just 2 USD. Okay, this is with the additional 6 zeros, which is necessitated for the internal representation here, right? So I transfer that to the deployed contract and send it in. See if that works. It looked like it came back appropriate. Now let's check that balance of my deployed contract, which was under DP. And now I have the associated amount. Okay, so now let's request the flash loan. Let's just do it. Okay, so here I'm going to request just one USDC, and I attach 6 zeros, and this is the difference, right, between the contract-based representations. I have to add for the to send in one USDC specified, I have to add the additional 6 zeros for that, right? So let me pass that. I take the value. I'm going to pass that into the TX variable for the transaction. And I can see this flash by on the node as well, updated. And I have the transaction occur, and everything looks appropriate. So the first thing did it really happen, right? It looked like it worked appropriately. I can go ahead now and let's check the balance of the token for the deploy contract. So if I do that, guess what? I have less than 2. It took that premium out of it, which was 0.0005 USDC. Okay, so it's a very nominal amount for the premium, right? If you recall, I had the 2 with 6 zeros just before that, right? So let's take a step deeper, okay? I want to have complete validation of exactly what happened, and just per the name, right? Flash, it sent it to me. I sent it back with the premium. Did everything work appropriately? It's looking really good. Now let's go the extra step. I have that transaction. From that, I can grab a lot of information for a lot of additional programming. And this can hopefully inspire a lot of additional utilities and operations and monitoring events, things like that you can actually program and automate, as opposed to just engaging directly with the Remix application, right? So here I'm going to define an ABI just for the transfer events. That's the primary operation. We could break down all the events. I don't want to go a deep dive on events and log files and transactions on Solidity. That can be a rabbit hole. We don't want to spend a lot of time on that. Okay, but here I'm just defining the event transfer as a ABI based definition. And I'm going to use that with the Ethers library. I'm going to pass that into the Ethers interface and define that interface. And from there, I can put together the means of breaking down those transaction logs. And I have to interpret them and have them converted to be human readable. Okay, so with the transaction hash, I can convert that into a receipt that is accomplished by doing get transaction receipt that you see down here. Lost my screen. And so from that, I'm going to get the TX receipt, and the advantage there is I can say TX receipt, and I have all my transaction logs, of which about 4 just blasted through the screen. I can iterate through them. Again, I'm only interested in looking at the transfer operations, but I can step through the logs and I can convert them as I go through. And it's not a lot of information. Instead of just building a whole application around this, I can take the interface that's defined, and from the interface, I can invoke the Ethers library, parse log, and I can take that transaction receipt logs, and I can just step through. Okay, and the first one is, lo and behold, okay, so I have the 2 addresses and the amount in that transfer operation. So recall back, if you've seen the Sepolia demonstration, you might want to look at that with the Etherscan Sepolia. We had the transfer event, and looking at that, it's very intuitive that the flash loan occurred, and I had 2 operations, a from and to and from and to. And in this case, this is the first one, right? And that's the amount. It's my 1 USDC. That's the amount, right? In UENT 256. And then I have 2 contract addresses. And let's pull up the deployed contract that's under DP very conveniently. And that's a 9CF6, right? That is the 2. And let's grab the contract address here. And I haven't referenced this prior, so I can punch this into Etherscan just to have a comfort level around that. And I can see that is the AAVE USDC v3 contract. Okay, so how do I interpret this? From AAVE is the from, and it's sending it to me. And that is the 1 USDC with the 6 zeros. There we go. So that's confirmed. I got the money. Okay. And let me just step back through this. I can step through. Of course, I'm going to get nulls. Why? Because in my interface, I only define the transfer event. So it's going to show up as null, not that it's blank, right? And if you look at the bare logs, this isn't human readable. Now it is with the parse log command. Okay, that allows me to convert it as such. And if I pull in my contract again, now in the from, that's me, right? It's giving it back. And then the 6F5C, that's AAVE contract up here that you see up here, the USDC v3 that you see up here. And here is the amount, as we specified in the flash loan contract, plus the premium, and that's sending it back. So I confirmed it through the transaction logs, and there you go. So I proved it. So we have looked at, we've forked the Ethernet mainnet. We deployed our contract. We checked the balance of the contract. It was depleted by the amount of the tokens that we loaded in through the account impersonation that we went through the transaction logs and actually verified through the contract addresses that the money was sent to me, and then immediately was returned within seconds, the amount plus the premium, and there's your flash loan. So there's basic mechanics. We're going to build on this, hopefully get into some content generating applications, including crypto arbitration, where you can actually do something with the money. But let's get that comfort level first, right? Of going through that mechanics, having the comfort level of borrowing a small amount and giving it right back with the premium and setting up to be run on a production network environment. Thanks for listening. Take care. And remember, as usual, all the content is going to be referenced on the associated GitHub. Cut paste through the README install file, and I have the project directory set up with the Hardhat config in this case and smart contract. Thank you. Take care. Have a great day.